Continuing on now with example number 2 for network flow. In the previous example, we determined the flow capacity of this network by considering the various paths. So you might recall this from the last video. Okay, so these were the various paths that we had identified and considered the capacity of each path. Okay, and then we ended up with this diagram. Okay, and with the spare capacities that are left over basically on each of these roads or each of these edges. So if anything with a 0 means that that road has been totally consumed. Okay, so but totally saturated with cars. Anything that doesn't have a 0, so for example SE, okay, we've got 40. That means that's 40 cars per minute of spare capacity. In other words, SE is too big. That road doesn't have to be that big. There's a few others as well. FD is way too big. I mean, we're 270 cars per minute too large, in fact. So what we're going to do is we're going to redraw or basically putting weights on each of these edges that reflect the exact capacity needed to get the maximum flow of a 930. So that was what we had determined in the last example. Okay, so again, I'm just going to use a red pen. I'm just going to draw over this diagram. So let's consider all the edges. So again, SCFD, T. All right. You need to consider the original capacity. So SC was originally 440, but after we did the whole analysis of determining the flow capacity, we found that we were 40 cars per minute too big. So what we're going to do is we're going to subtract 40 from 440, and that'll in fact be our new capacity. So the capacity that we actually need for SE is in fact 400, because that's actually what's being piped through SE at the moment. That's the number of cars that are going through SE. The road is big enough to handle 440, but there's only 400 going through, so SE only has to be 400. EF is 0, which means that it's at capacity. FD, so 530 minus 270, we've got 260. Okay, that's our new capacity there. And we've got DT, so starting off at 710, we end up with 80 cars per minute spare. So we end up with 630 is the capacity that we need for DT. Okay, AT is 0, so that's at capacity. SA is 0 as well. SB got 320 starting off with. We end up with a spare capacity of 60. So 320 take away 60 is 260. Okay, so 260 there. BC is at capacity. In fact, AC never even got used. So AC is totally redundant. In fact, that capacity there, in fact, can be 0. AC never got used at all. Now, you may end up with a slightly different answer. It doesn't actually matter. It really depends on which paths that you considered. If you did consider SB, AC, DT, then AC would have been used, and then you might have some slightly different numbers. But this is it's not the only solution, but it's one of many solutions. Okay, so AC didn't even get used at all. So we've got 230 spare. It's a spare road. We can even get rid of that road altogether. CD is 0, so that can stay at 370. EC, we start off at 180. We end up with 40 spare, which means that the actual capacity that we need is 140. Okay, I'm just trying to think if there's anything else. Yep, we've got BA, 290 starting off with. We end up with a capacity of 260, which means that there's actually 30 cars per minute going through BA there. All right, I think we've considered all the edges. Just make sure we count through. So SC is done. Yep, that's on. EF, all the ones that have 0, make sure, well, we don't have to do anything there. CD's fine. DT we've considered. BC we've considered. Yep, I think that's done. And that's our new network diagram. We can transcribe that onto a brand new one. So I could have copied it onto this sheet there, but I think as long as you can show that, you know, these are the new capacities, these capacities will ensure that the maximum flow is still reached without having roads that are bigger than what is required.